Hello, so I'm a bit late. Let me load up chat real quick. Distracted installing stuff on my computer. Okay, so hello, Algebra 2. It's Thursday, May 21st. We have shaky computer. A couple weeks left of school, and if you're a senior, you have today and tomorrow to get your grades in. So I've been messaging some of you, but you're running out of time. Running out of time. So yeah, this has been a known thing. So it shouldn't be surprising. And this camera, I don't understand why it's so laggy. Should be better. Okay, sorry. Trying to fix video stuff. It's still on. I don't know why that is. Just gonna be what it is. We have. I'm gonna spend about 20 minutes. We're gonna talk about tangent and the graph for tangent and cotangent. So on Tuesday we talked about sine and cosine, what those graphs look like. And today I want to talk about tangent. So we're going to start with the whiteboard. We are going to be using unit circle stuff. Now here's the thing. Tangent is just sine and cosine. So tangent of theta, whatever angle value in degrees or in radians, is the same as sine of that angle divided by cosine of that angle. This is the definition. Which when we simplify those, when we use our opposite over adjacent language, this is what we get. We get the opposite side divided by the adjacent side. And that's in our unit circle. So if I have my unit circle here, remember the radius is 1. I'm using, say, this triangle. This would be the opposite side. Here's angle theta, and this would be the adjacent side. So tangent is the relationship there. And clearly it's going to change, right? As this triangle moves, the length of those sides, the adjacent side gets shorter and the opposite side gets taller until it gets over here, and then it starts switching that relationship. But there's some key points. Here, when the angle is 0, and theta is 0, this adjacent side is going to be 1, and the opposite side is going to be 0. So tan of 0 is 0. When we get to 90 degrees, or pi over 2, right, this vertical line, this vertical line, the adjacent side is going to be 0, and the opposite side, the height, is going to be 1. So there we get tan of pi over 2 is 1 divided by 0. And you might be thinking, well, we just divided by 0. How does that work? Well, that's undefined. Okay, so now I want to look at Desmos, and we'll talk about the graph of the curve. Not just like where it is on the unit circle, but the relationship when we divide the opposite and adjacent side. What are the values that come out? So our function is y equals tangent theta, tan x. Okay, so here is Desmos. We're going to graph. Yeah, the stream is lagging. I don't know what's going on. I'm just going to forge ahead. So y equals tan x. We get that. Before we do that, I want to start with sine x. Y equals cosine x. And this is y equals tan x. We're going to hide the tangent x, though. So here are our curves from Tuesday that we looked at. Check notes is a little thicker. We have right? Our horizontal axis here, this thing. We have the period, which repeats every 2 pi. So there it repeats there, and for cosine, it repeats there at 2 pi. That's the period. The amplitude is how high they are, how much they've been stretched or shrunk. Now, cotangent is just the value of the red line divided by the value of the blue line. So when we're here at 0, we're dividing this red value 0 by 1, the y value. 0 divided by 1, which you get 0. You'll notice as this gets bigger, we're dividing a larger number by a number that gets smaller and negative. So at some point, we're dividing a positive number, 0.614, by negative 0.77. When we turn on tangent, it's going to go up, but then it switches to being negative. As soon as this blue line switches negative, then they're both negative, and it goes positive. It's positive. Negative divided by negative makes positive. And then it switches to positive divided by negative, so it's negative again. So the green line is our tangent line, and it repeats. And you'll notice right here at x equals pi divided by 2, that's where the tangent line, I'm going to hide these, disappears. And we could zoom way out. And it's hard to tell because we're on a computer, and it looks like it all just blurs together. But those lines never cross. Never. Never cross. So it starts looking like they cross, but if I zoom in, they will never, ever touch each other. They just get really close. And that is called an asymptote. An asymptote. It's a fun word, I guess, which is our first vocab word in our student journal, which is in the Dropbox folder. You should have access to that. So the asymptote is where the graph is undefined. It does not exist. When I put in tangent pi divided by 2, it says the answer here is undefined. Because it's not defined there. It doesn't exist. The graph does not exist. Okay? This also has a period. We start at 0, right? And then it's going to go up, and it's going to go flip back down here and start over here. So from there to there, the period on tangent is shorter because we're dividing sine by cosine, so it's melding those two. So it repeats more often. So its period is only every pi. I mean, it is also, it repeats every 2 pi, but there's 2 copies inside that 2 pi. All right. We have an asymptote, the period, the amplitude. We can stretch and shrink tangent. We can stretch and shrink it. So we wanted to do y equals a tan bx minus h plus k, like we did last time. We should actually be here. Should look like that. All right, and we turn those on sliders. You'll notice the red line here is the tangent, and we can make those match up by what we did last time. We make h0, because h moves it left and right. You want to be at 0, sorry. And k moves it up and down. You see that curve moving up and down. It looks like it's bending, but it's not actually bending. It's just not people looking with the green line. So there they match up. And I can move it up, or I can move that curve down. And it looks like it's bending, but it's not actually bending. If I want to bend it, we multiply by b here. This increases the period. It squishes them together, or flips them when it's negative. Notice when it's a fraction, it stretches them out. Also changes the period. This is how I set up the equation. And then A here changes the amplitude. It just multiplies and divides the number, so it stretches it. Okay? So we can still do the same transformations to tangent. Now, tangent goes with cotangent. Y equals cotangent of x. And it's just the same graph flipped over. It's the same function. It's this one, this red one. It's just the tangent function flipped, reversed, and translated. So it's not exactly the same. You'll notice that the asymptote is now at 0 and pi instead of pi over 2. Okay, that's because now we're dividing cosine, and we're dividing cotangent is cosine divided by sine instead of sine divided by cosine. Okay, and then we can put all those together and we get this. Let me show you what tangent looks like. Transformations, we can shift it. Alright, we have the domain. The domain is all reals except multiples of pi, right? Because, or 2 pi over 2, because that's where the asymptotes are. Vertical asymptotes. Period is pi, x-intercepts every interval. Yeah, that's it. We have some functions to describe those things. And then secant and cosecant are 1 over sine and 1 over cosine. So let's talk about this. I'm going to clear out these functions, all the tangent ones. All right, so sine and cosine. Let's get rid of cosine. So y equals 1 over cosine x. This is the function for secant. And then y equals 1 over sine x. It's the same thing, it's just shifted over. Notice it starts at 1 here, like the, so this one goes with this one. Notice they're connected. You may have seen this pattern before in like art or something. And then the sine one is the same, it's just shifted over. And the reason it does that, it also has vertical asymptotes here at pi, or pi over 2, because they're basically the same graph. But we could, multiply this by 2, and then it shifts up. It's no longer, it's been stretched. It's no longer starting at 1. And we could do our same kind of transformations. We could put 2 here. It makes it wider. We could put 2 on the inside. It makes it skinnier. We could add to it. Shifts it around. Yeah, we have our same transformations. Okay? So those are all the graphs for all the functions. All right, and if we put them all in here, it gets really busy. Really busy. But it also seems like there's some art to it. Yeah. And you notice they're all kind of centered around these subdivisions of pi and 2 pi and those things. Okay? And all these graphs go on forever. Okay, so those are the things. They have periods, they have asymptotes, they have amplitudes, and then it would want you to graph these. Okay, so if you were doing the student journal, I would use a graphing calculator. You can do these by hand by plugging in values for x and then figuring out kind of where those are. We would have done that, but we're not going to go that in depth because school's almost done, people. That's it. Trig functions. If you're going into trig next year, or calculus, you're going to be doing a lot with these. If you're going to stat next year, you're going to be doing more probability stuff, which I don't think will make time for. Maybe you go look at the rest of the chapter and be like, we're not going to do all this stuff. Let's look at some statistics. That's it. That is it. That is it today. I hope your Thursday is going well. Remember, turn stuff in. Send it to me on Remind. Sorry, this is stuff on my phone. Send it to me on Remind or my email. And have a good weekend. If you're a senior, you got till tomorrow. You got stuff to turn in. It's 2:15. You've got 24 hours. And I'm gonna check my email in a minute because I've probably got some emails or some work, but got about 24 hours before you let your stuff in. If you're looking in your gradebook, there's assignments that have been added, not by me, but by the district, that are just communication tools for me to. They're not for points. Like, it's not going to change your grade. But the numbers in there represent, like, oh, I did a stream, we did a Zoom call, you showed up for it, you turned in work. That's what those numbers mean. And then, like, oh, I want a counselor to contact you because your grade is low and need some extra motivation. Those kinds of things. So don't worry about those numbers. They're largely meaningless for you, but they're for the district to get data on students and teacher interactions and stuff like that. So don't worry about it. Don't worry if there are zeros in there, it's okay. Don't worry if it's a 5 or a 3. It just means each of those is like a code. So you don't need to worry about it. Alright? Have a good weekend. I will see you guys on Tuesday. We'll probably do another Zoom call next week on Friday. And that's it. Have a good weekend.